Okay, we're going to do some graphical problem solving with the first CVPM practice problem. The difference between here and algebraic is instead of using the diagram to come up with our models, we use the graph as a starting place, but the end will be the same. So I'm going to draw a position versus time graph for the motion, maybe a little bigger one. I know from the description they need to start at the same spot. Where they start is arbitrary. I'll just pick the origin, but it doesn't really matter. So one goes in one direction. We'll say this is Creed, and the slope of that is his velocity of 4 meters per second. And then Kevin goes the other direction, so his graph needs to slope down. And his velocity is unknown. We do know some other stuff here. We do need to label some other stuff here. Here's the delta t, and that's for both. I'm going to do my problem solving in terms of distances instead of delta x, because one of our delta x's is negative, one of our velocities is negative. I'm going to work in terms of speed and distance so that the relationships are a little easier to set up. You can work either way. So the distance that Creed travels is 5.1 meters. Distance that Kevin travels, which would be positive even though his displacement is negative, is unknown. And the total distance between them at the beginning, or at the end rather, is 8 meters. So, since what I'm trying to find out is Kevin's speed, what I need to do is figure out the slope of this line. So that's the place I'm going to start. And really the absolute value of the slope is what I'm looking for. So I can tell that right away from the graph. Unfortunately, I don't know dk or delta t. So what I can do is figure out what dk is from over here. If I look, I can see pretty clearly that dk is d minus dc. So I'm going to sub that in for dk. And we can also do this with more algebra by, setting up what the d's equal in terms of the v's and the delta t, and then setting up this relationship and solving the three simultaneous. You can do that if you want. That'll certainly always work if you don't, have any inspiration, but I'm going to try to do it the easiest way I can. So we need the delta t. The delta t is the same for both, we can see on our graph. So for Creed, I know that his speed is the distance that he travels over delta t, so delta t is the distance that he travels over his speed, and I can sub that in here. And I'm going to clean that up because you never want to leave a compound fraction like that, or a compound fraction at all. Okay, before I plug in numbers, I'm going to check my units. This subtraction is okay. You always want to check your additions and subtractions, make sure that they're the same units, and they're both meters, so that's fine. When I take this quantity in meters and divide it by this quantity in meters, the units will cancel, and I'll be left with the units of the speed, which is exactly what I wanted, so that's a good sign. Alright, so I plug all those numbers in that I know, and I get 2.27 meters per second, and notice that is a speed, not a velocity. His velocity here, given our choice, was negative 2.27 meters per second. Alright.